In this video, we are going to write the equation for exponential functions, both that grow and decay over time. So we'll be looking at, with growth, we'll be looking at exponential functions that grow over time. So notice how as x increases, y is going up. We can see that growth. With decay, we'll be focusing on something that decreases over time. So notice that as time goes by, we are getting very, very close to that axis there. So we'll be looking at both cases. How do we write them for exponential growth, and how do we write them for exponential decay? So in this slide, I have three exponential functions graphed. We have y equals 2 times 4 to the power of x. I have y equals 1 times 3 to the power of x. And y equals negative 2 times 2 to the power of x. And what I want you to take a very close look at is the y-intercept point for each of these graphs. Remember, our y-intercept point is where we cross the y-axis. And here's our y-axis for each one. And so if we take a close look, here's our y-intercept point of this first function. Here's our y-intercept point of the second function. And here is our y-intercept point of this third function. And what you are hopefully noticing is that the y-intercept point, that 2, 1, and negative 2, can all be found in our function. If you look closely, each function contains that y-intercept value. And that y-intercept value is your value without the x exponent. So moving forward, what you should be able to do is you should be able to look at a graph, find the y-intercept, and put it into your function. But you should also be able to look at your equation, identify your y-intercept, and plot it on your graph. So we now know that there's an important connection between the equation and the graph, and we're going to use this connection as we start to write exponential functions. So now let's take a look at the tables here, because there's actually another piece of information that our equation contains. So if we take a look at the patterns in each table, notice here we go from 1/8 to 1/2, 1/2 to 2, 2 to 8, and 8 to 32. And while it's not super obvious at the very, very beginning, what I do notice here towards the end is I notice this multiplication of 4. So 2 times 4 is 8. 8 times 4 is 32. And then if I kind of look back, what I notice is, well, 1/2 times 4 is 2, and 1/8 times 4 is 1/2. So what I'm noticing here is I'm having this multiplying value of 4 appear multiple times. And what I also notice is that if I look into my equation, there's a 4 to the power of x there. So I'm noticing that as x increases by 1, I'm continuously multiplying the consecutive y values by 4. And let's see if this same pattern pops up in other tables. So here I notice, okay, my value attached to the x is a 3. So I'm hoping I see something with a connection to 3. So here I notice, okay, 1 times 3 is 3. 3 times 3 is 9. 1/3 times 3 is 1. 1/9 times 3 is 1/3. So again, I'm seeing that as x increases by 1, my y values are constantly being multiplied by 3. And then here in this final table, I'm noticing the same thing. I'm multiplying by 2, multiplying by 2, multiplying by 2, and multiplying by 2 to get to my consecutive y values as x increases by 1. So not only does this equation contain the y-intercept value with the term that does not have an x, we also have what's called our multiplier value. What are we multiplying by to get our consecutive y values in our table? So now what we're going to do here is we're going to write our exponential function equations given the tables that we see. So to generalize this a little bit, an exponential function in general is y equals a times b to the power of x. And remember from the previous slides that these a and b values represent something important. This a value, or this value without the x value, is our y-intercept. That's where we're crossing the y-axis. And this b value, the value that contains the x as an exponent, is what's called our multiplier, or it's that pattern that we see in our table to get to consecutive y values. So as we go to write our equations, let's start looking for this key information. Can we find our y-intercept value, or can we find our multiplier value, and then substitute them into our equation? So the first thing I'm going to look for is I'm going to look for my a value, or my y-intercept value. And if I look at this first example here in example A, remember my y-intercept value is actually a point, and it's a point where x is 0 and y is some number. So if I look at my table here, I can find my y-intercept point, or I can find where I cross the y-axis if I look for where x is 0. And what I notice right here is that when x is 0, y is 8. So that is telling me that my y-intercept point is when x is 0 and y is 8. So what that's telling me here is that my a value is equal to 8. That is where I am crossing the y-axis. So I found my first piece of information. Now from here, I also need to find my multiplier value, which I need to look for, okay, as x increases by 1, what is the pattern that I see happening to y? And here what I notice is that I'm taking consecutive y values and I am multiplying them by 2. So because I have this consistent multiplier value of 2, my b value is equal to 2. So what I can now do is I can take these two values and I can substitute them into my equation. So here I have y is equal to my a value of 8 times my b value of 2 to the power of x. Now if I apply this same thinking to part B, again I'm going to start by looking for my y-intercept value so that I can find my a value. And I know that my y-intercept value occurs when x is 0, and my y value here happens to be 1/9. So because when x is 0, my y value is 1/9, my a value is also 1/9. Then from here I'm looking for a pattern in the table. This is a little bit more difficult to see. Sometimes it's easier to look at the last few. But I know that 1/3 times 3 is what gives me 1. And then I think, okay, 1/9 times 3 would give me 1/3. 1/27 times 3 gives me 1/9. And 1/81 times 3 gives me a 27th. And remember, we have to look at what's happening to the y values as x increases. So over time, I'm taking these y values and I am multiplying them consecutively by 3. So my b value is therefore 3. So then from here I can take my key information. I have y equals my y-intercept value times my multiplier value to the power of x. And last example here. So again, I'm looking for my y-intercept value to start. So I know that that occurs when x is 0. So I have x is 0, y is 27. So as a result, my y-intercept value and my a value are both 27. And then from here, I need to look for a pattern, and I notice that as x increases, my y values are multiplying by 3. So my b value, therefore, is equal to 3. So So now I go to write my equation. I have y is equal to my a value of 27 times my b value of 3 to the power of x. So now that we've mastered the exponential growth equations, let's take a look at exponential decay equations. So we're going to have the same ultimate model here of y is equal to a times b to the power of x. And a and b still represent the same values. Remember, a is our y-intercept value, and b is our multiplier. So let's see if we can determine any of this information from the picture of the table that we see. So to start, what I remember is that my y-intercept point is going to be when x is 0 and y is a number. And what I notice here is that when x is 0, y is 1. And so as a result, I know that my a value is equal to 1. Then from here, I want to go looking for my multiplier value. But what I notice instead is that over time, I seem to be dividing by 5. So as x is increasing, it seems like I'm dividing by 5, which is fine, except for multiplier means that I need to consistently multiply by something. And here I'm consistently dividing by something. Now, there is a direct relationship between division and multiplication. Remember previously when we were doing any sort of division, say we had 1/2 divided by 5. We could use the keep, switch, flip method to turn this into 1/2 times the reciprocal of 1 over 5. And we can do that same thing here. Division of 5 and multiplication of 1/5 are exactly the same thing. So what we can do here is we can say, yes, we notice we have a pattern where we're dividing by 5, but we're going to write it in terms of multiplication, which is multiplying by a 1/5. So if we see repeated division, we can easily turn that into repeated multiplication by using the reciprocal. So here, what's really happening is my b value, as I'm repeatedly multiplying by 1/5, so my b value is 1/5. So then I can go to my equation, and I write y is equal to my a value of 1 times my b value, I'm going to put in parentheses to keep it safe as a fraction, to the power of x. Let's try to write a couple more exponential functions. So remember, we're going to be in the form y equals a times b to the power of x, where a is your y-intercept value and b is that multiplier value that we are consistently multiplying those y values by. So let's start off by looking at this first one here. Remember, our y-intercept value is when x is 0. So when x is 0, I notice that y is 10. So I know that my a value is equal to 10. I then notice that over time, I seem to be dividing by 5. So 50 divided by 5 is 10. 10 divided by 5 is 2. 2 divided by 5 is 0.4. And I remember that division of 5 is really multiplying by 1/5. So my multiplier value here, since I'm repeatedly dividing by 5, is I am repeatedly multiplying by 1/5. So then from here I can take these two values and I can write my equation. So I have y is equal to my a value of 10 times my b value of 1/5 to the power of x. Then here I look at my second example. My y-intercept value is when x is 0, and I notice when x is 0, y is 2. So my a value is my y-intercept value of 2. Then from here, I'm looking to find my b value, or my multiplier. And what I notice as my x values increase by 1, my y values are dividing by 3. Dividing by 3. Dividing by 3. And I know that division of 3 can really be represented as a multiplication of its reciprocal of 1/3. So my b value here is really equal to multiplying by 1/3. Then from here I take both of these values, so I have y is equal to 2 times 1/3 all raised to the power of x. And then finally, my last problem here, I start by finding my y-intercept value, which is x is 0, y is 8. So I know that my a value is equal to 8. Then from here, I look for a multiplier. I notice that as x increases by 1, my y values are being multiplied by 4. So my b value is just simply 4 because I am multiplying everything by 4. So here, in order to write my equation, I take y is equal to my a value of 8 times my b value of 4 to the power of